Hi viewers, welcome back to the channel. In today's video, we will be going through exercise 5.3 from the chapter Squares and Square Roots for grade 8, and we will look at each question step by step and understand the solutions clearly. So let's begin. We'll start from first question. What could be the possible ones digit of the square root of the each of the following numbers? So without calculation, you will tell what will be the unit digit of the square root of the given number. So before solving this question, first of all, we will write down the squares of number starting from 0 till 9. Okay, so square of 0 is 0, square of 1 is 1, and when you find the square of 1 you get 1 and the unit digit is 1 here. When you find square of 2 you get 4 at the unit place. Similarly, when you find the square of 3 you get 9 at the unit place. Square of 4 will give you 6 at the unit place. Square of 5 will give you 5 at the unit place. Square of 6 will give you 36 and 6 at the unit place. Square of 7 will give you 49, 9 at the unit place. Square of 8 will give you 64, 4 at the unit place. And square of 9 will give you 81, 1 at the unit place. Okay, now we'll start solving the question. See, when you find square root of 9801, what will be the unit? What will be the digit at the unit place? Now look at the right hand side. When you are getting 1 at the unit place, see, when you do square of 1 and when you take square of 9, you get square or you get 1 at the unit place. So answer is 1 or 9. It means whenever you will find the square root of 9801, you will get 1 or 9 at the unit place. Now we'll start from we'll do the second part. It is given digit is 99856. It means now if you find square root of this number, which digit will come at the unit place? Now again look at the right hand side. When you are getting 6 at the unit place, when you take square of 4, you get 6 at the unit place. And when you take square of 6, again you get 6 at the unit place. So answer is 4 or 6. It means whenever you will find the square root of 99856, in the answer you will get 4 at the unit place or 6 at the unit place. Okay. Now the third part, it is 998001. Already we have solved part 1. When it will end, if the number is ending with 1, then what are the possible digit at the unit place? See, when you take square of 1 or when you take square of 9, you get 1 at the unit place. So answer is 1 or 9. Now look at the fourth part. Number is 657666025. See, the number is ending with 5. It means when you find the square root of this number, now look at the right hand side. When it is ending with 5, whenever you take square of 5, the unit digit is 5 here. In 25, unit digit is 5. It means when you find the square root of this number, the digit at the unit place will be 5 only. Now look at the second question. Without doing any calculation, find the numbers which are surely not perfect squares. So no need to do any calculation. By just looking at the number, you can explain that why the given number is not a perfect square. See, the perfect squares, they always end with these digits only. Either 0 or 1 or 4 or 5 or 6 or 9. So what you will do, you will just look at the unit digit. See, in the first question, the unit digit is 3. So you can easily write that this number is not a perfect square because it is not ending with 0, 1, 4, 6 or 9. Okay. Now look at the second question. It is 257. Okay, which digit is at a unit place? It is 7. So you can write it is not a perfect square because it is not ending with 0, 1, 4, 5, 6 or 9. Now look at the third question, 408. Same answer you will write this time also. It is ending with 8, or you can say the digit at unit place is 8, so it is not a perfect square. Now fourth, it is 441. It is ending with 1. Now if you find the square root of 441, you will get 21 as the answer. So 441 is a perfect square. Okay. Now look at the third question. Find the square root of 100 and 169 by repeated subtraction. So repeated subtraction is also one of the way to find the square roots. Usually this method is used when you need to find the square roots of smaller numbers or which are the perfect squares. Okay. So in how we what we do in this method that you will start subtracting odd numbers starting from 1. Okay, let's see. We will do step by step. See, from 100 You will first subtract 1. When you subtract 1 from 100, you get 99, right? Now what you will do, you will subtract 3 from 99 because which odd number comes just after 1? It is 3. Now you will subtract 5 from 96, you get 91. Now from 91 you subtract 7, which is the next odd number. We will keep doing this till you get 0, right? So now you subtracted 9 from 84 and you get 75. From 75 subtract 11, you get 64. From 64 subtract 13, you get 51. From 51 subtract 15 to get 36. From 36 subtract 17 and you get 19. Now from 19 you subtract 19 and you get 0 at the end. Now you will stop your subtraction here. Now in how many steps you achieved 0? You got 0 in 10 steps. 10 steps. So the square root of 100 is 10. Now with the same way we are going to find the square root of 169. So what you are going to do, you will subtract 1 from 169. Now subtract 3, 5, 7, 9, 11. Next 13. Now you subtract 15, 17, 19, 21, 23, 25. And when you subtract 25 from 25, you get 0, right? So now you will stop your subtraction here. Now in how many steps you achieved 0? In total 13 steps, you got 0 at the end. So that is why the square root of 169 is 13. Now we will start solving question number 4. Find the square roots of the following by prime factorization method. See, prime factorization method in detail I have covered in my previous video. What we do in this method, you will make prime factors of the given number. So the first question arises that what are prime numbers? Prime numbers are those which are divisible by themselves or by 1. Okay, so we will again see this method by taking the first question. See, now you need to find the square root of 729. So you will, what you will do, 729 is divisible by 3 and 3 is a prime number. So when you divide 729 by 3, you get 243. Now again divide it by 3. What you get 81 as the answer. Now 81 is again divisible by 3. What we get after this, you get 27. Divide again it by 3. You get 9 and 9 is divisible by 3. Okay, so now at the end you will divide 3 by 3 and you get 1 at the end. So we will stop our division here. So now you can write 729 as the product of all these factors. Okay, so write them in the product form. All threes you will write in this form. Now the next step is pairing. Why we are doing pairing? Because you are finding square root. In the square root you form pair of similar factors. So next step is forming of pair. So 3 and 3 forms a pair, then 3 and 3 forms a pair, and next 3 and 3 forms another pair. So we formed here 3 pairs. So you can write 729 as 3 square, then again multiply by 3 square, and then again 3 square. And the next step is we want square root. So you will put square root sign and you will take only one factor. So you will write the square root of 729 is 3 times 3 and again times 3. So square root of 729 is 27. Now we'll solve the second question. It is find the square root of 400 by prime factorization method. Since this 400 is ending with 0, it means it is divisible by 2. So when you divide 400 by 2, you get 200. Divide 200 by 2, you get 100. Now 100 is again divisible by 2. When you divide 100 by 2, you get 50. 50 is again divisible by 2, you get 25. Now 25 is divisible by 5. So when you divide 25 by 5, you get 5. And again divide 5 by 5, you get 1 as the answer. Now since you get 1 at the end, it means you will stop your division here. 400 can be written as product of all these factors. And all these factors are prime factors. Now the next step is you will start forming pairs of similar factor. See 2 and 2 forms a pair. Next 2 and 2 forms another pair and 5 and 5 forms another pair. It means 400 can be written as 2 square multiply by 2 square multiply by 2 square. When you find square root of 400, you will take one time only. Now 2 you will take one time, and next 2 you will take one time, and next 5 you will take once only. So the square root of 400 is 2 times 2 multiplied by 5 will give you 20. So square root of 400 is 20. Now let's do third sum together. It is the square root of 1764. See, learning is fun when we do it step by step. Okay, so always do your sums step by step. Okay, now we'll again follow the same steps. 1764, it is divisible by 2 because it is an even number. So when you divide it by 2, what we get? We get 882. Now 882 is again divisible by 2. What we get? 441. 441 is not divisible by 2. So this time you can try 3. So when you divide 441 by 3, you get 147. 147 is divisible by 7. You get 21. Again you try 7, you get 3. And at the end you will divide 3 by 3 and we get 1 at the end. So what is the next step? I think you all know now. You can write 1764 as the product of all these prime factors. Okay. And what is the next step? I think you all know now that we will now form pair of similar factors. So you can write 1764 as the product of 2 square and then 3 square and then 7 square. What is our motive here? Our motive here is to find the square root. So on the left hand side you will put square root sign, and at the right hand side you will only take these factor once because we are taking square root now. And square root of 1764 is 2 times 3 and times 7, which will give you 42. So the square root of 1764 is 42. Now find the square root of 4096 by prime factorization method. See, 4096 is ending with an even digit, so it means it is divisible by 2. So start dividing 4096 by 2. When you divide it by 2, you get 2048. 2048 is again ending with an even number, it means it is divisible by 2. On dividing, you get 1024. Again divide it by 2. You get 512. 512 is divisible by 2. On dividing, you get 256. 256 is divisible by 2. On dividing, you get 128. 128 on dividing by 2, you get 64. Divide 64 by 2, again you get 32. On dividing 32 by 2, you get 16. 16 is divisible by 2, you get 8. 8 on dividing by 2, you get 4. 4 is divisible by 2 and you get 2. 2 is again divisible by 2 and you get 1. Okay, now you got 1 at the end. It means you can stop your division here. So 4096 can be written as product of all these prime factors. After writing this, start making pairs. You will make pairs of similar factors. Now 4096 can be written as squares of, it can be written as 2 square, multiply by 2 square, again multiply by 2 square, multiply by 2 square. So 1, 2, 3, 4, 5, 6. So we form 6 pairs of 2 here. So when you find the square root, you will take 2 6 times. So the square root of 4096 is, you will multiply these two and you will get 64 as the answer. So square root of 4096 is 64. I think you all have become so perfect in finding square roots. So now let's find the square root of 7744 together. By the same method, prime factorization method, write down the number first. So the first step is you will look at the unit digit. If the unit digit is a even number, it means the whole number is even and you will divide it by 2. When you divide it by 2, what we get? You get 3872. The next number is again even. So again try with 2. You get 1936. Divide again it by 2. We get 968, which is again divisible by 2. We get 484. That is again divisible by 2. And that gives us 242. Divide again by 2. You get 121. See, 121 is not an even number and it is divisible only by 11. So write down 11 and at the end you get 11. So again divide this number by 11 and at the end now you get 1. It means now you will stop your division here and you can write 7744 as a product of all these prime numbers. Now the next step, you all know we will form pairs of similar factors. Now start forming pairs. So you can write 7744 as the product of 2 square, again 2 square, then again 2 square and 11 square. Okay, but our motive is to find square root. So now put square root sign on the left hand side and on the right hand side, we will take all these factor ones only because we are finding square root. So you can write square root of 7744 as 88. Okay, you will do the multiplication of all these numbers so that you will get answer as 88. See, that wasn't so hard, right? So now we'll do the next sum. Now we'll solve the next sum, square root of 9604. Now start finding prime factorization. So divide it by 2, you get 4802. 4802 on dividing by 2, you get 2401. 2401 on dividing by 7. So it is not divisible by 2, and 7 is also a prime number. So you get 343. 343 is divisible by 7, you get 49. 49 on dividing by 7, you get 7. Again, divide 7 by 7, you get 1 as the answer. So 9604 can be written as the product of all these factors. So what is the next step? You will start forming pairs. Start forming pairs now. So 9604 can be written as 2 square multiplied by 7 square multiplied by 7 square. Now you're looking for square root of 9604, so it will give you 2 multiplied by 7 multiplied by 7. So square root of 9604 is 98. Now let's find the square root of 5929 together. Okay, the first step is you will see like by which number it is divisible. Now, if you see it, it is an odd number, so it means it is not divisible by 2, and it is not divisible by 3, and it is not divisible by 5 also because it is not ending with 0 or 5. So you can try 7, and yes, it is divisible by 7. So don't be afraid of tough problems. There are opportunities to grow and to learn more and more. Okay. Now let's try it with 7. So when you divide 5929 by 7, what you get? You get 847. And next time again you try it by 7 because you need to form pairs, right? And when you divide 847 by 7, what you get? You get 121. And as I told you in the previous also that 121 is divisible by 11, right? And when you divide it by 11, you get 11 at the end. Again divide it by 11 and you get 1 at the end. Now you can write 5929 as the product of these factors, right? And what is our next step? Next step is formation of pairing. You will pair the numbers now. So it can be written as 7 square times 11 square. So now the next step is you will put the square root sign and you will take all these factor ones only. So 7 times 11 will give you 77. So the square root of given number is 77. Let's find the square root of 9216. See, 9216 is ending with an even number. It means it is divisible by 2. Now divided by 2, we get 4608. Again divided by 2, you get 2304. 2304 is divisible by 2. You get 1152. 1152 is again divisible by 2. You get 576. 576 on dividing by 2, you get 288. 288 is divisible by 2, you get 144. 144 is again divisible by 2, you get 72. 72 on dividing by 2, you get 36. 36 again divide by 2, you get 18. 18 you divide by 2, you get 9. 9 is not divisible by 2, so it is divisible by 3. You get 3 as the remainder. Now again divide 3 by 3, you get 1 as the answer. Now write 9216 as a product of all these prime factors. Next step is pairing. Form the pair of similar factors. So 9216 can be written as 2 square multiplied by 2 square multiplied by 2 square multiplied by 2 square. Again multiply by 2 square and at the end multiply by 3 square. We are looking for square root of 9216. So you will take all these factors only once. So 9216 can be written as product of all these factors. And when you multiply all these factors, you will get 96 as the answer. So the square root of 9216 is 96. Let's find the factors of 529. See, 529 is only divisible by 23 and 23 is a prime number. So when you divide 529 by 23, you get 23 as a remainder. Again divided by 23, so you get 1 as the remainder. So the factors of prime factors of 529 is 23 and 23. Now you form pair, so it can be written as 23 square. When you find the square root of 529, you get 23 as the answer. Okay, so the square root of 529 is 23. Let's see the square root of 8100 by prime factorization. 8100 divided by 2, you get 4050 as the answer. Again divided by 2, you get 2025. Now since 2025 is ending with 5, now straight away you can try 5. Now when you divide it by 5, you get 405. 405 is divisible by 5, you get 81. 81 we know that it is divisible by 3, you get 27. Divide again it by 3, you get 9. 9 is divisible by 3, you get 3. and 3 on dividing by 3, you get 1 as the answer. So 8100 can be written as the product of all these factors. Now what is the next step? You will start forming pairs now of similar factor. So 8100 can be written as the squares of 2, 5, 3 and 3. Now when you find the square root, you will take all these factors ones only. So 8100 is 2 multiplied by 5 multiplied by 3 multiplied by 3. The square root of 8100 is this. And when you multiply all these numbers, you get 90 as the answer. So the square root of 8100 is 90. Now let's start the fifth question. See, find the smallest whole number by which the following number should be multiplied to get a perfect square, and find the square root of the square number obtained. It means that the given number is not a perfect square. Okay, so we will first solve it by using the prime factorization method only. Okay, so write 252. It is divisible by 2. Divided by 2, you get 126. See, 126 is ending with even number. It means it is divisible by 2. Divide it by 2, you get 63. 63 you can divide by 3. It is divisible by 3. You get 21. Again divided by 3, you get 7. Also 7 on dividing by 7, you get 1. Now you can write 252 as the product of all these factors. Now what is the next step? Since we are trying to find square root. So we will form squares of number. Pairing of number we will do. Now 2 and 2 forms a pair and 3 and 3 forms a pair. Now if you see 7 is alone here. Now in the question it is being asked that find the smallest whole number by which the following number should be multiplied to get a perfect square. So if I multiply this number by 7, the 7 will also become a pair only. So what we are going to do, we will multiply this whole thing by 7. So on the left hand side, first multiply 252 by 7. And on the right hand side, you will again multiply it by 7. What this thing will do? This thing will form a pair of 7. Now on the left hand side, on multiplying it by 7, you get 1764. And on the right hand side, you will write the squares of all these number. So it will become 2 square, 3 square. Now 7 is also a pair, so you will write 7 square. Now when you find the square root of 1764, now you will take all these number ones only. So it will become 2 multiplied by 3 multiplied by 7, which will give you 42. So the square root of 1764 is 42. Now the question was, find the smallest whole number by which the number should be multiplied. So which whole number we multiplied? We multiplied this whole term by 7 to make it a perfect square. So 1764 is a perfect square and the square root of 1764 is 42. Now again we need to find the how to make 180 a perfect square. It is not a perfect square. Again we'll start by using prime factorization method. See 180 you can divide it by 3. When you divide it by 3 you get 60. Divide again 60 by 3 you get 20. 20 is divisible by 2 you get 10 as the answer. On dividing 10 by 2 you get 5. And at the end divide 5 by 5 you get 1 as the answer. It means 180 can be written as a product of all these prime factors. Now the next step is formation of pairs. 3 and 3 forms a pair, 5 and 2 forms a pair. If you see 5 doesn't have a pair, now you need to convert it into a perfect square. It means you need to multiply it by 5 only to make it a perfect square. So what you will do on the left hand side, multiply 180 by 5. And on the right hand side, 5 will also get a pair. It means now you can write 180 multiplied by 5 will give you 900. And on the right hand side, now everything has a pair. 3 has a pair, 2 has a pair, and 5 has a pair. So it can be written as 3 square multiplied by 2 square multiplied by 5 square. Now we are looking for square root of the new number form. So square root of 900 is, you will take only these factor once. So it will be 3 multiplied by 2 multiplied by 5. So the square root of 900 is 30. Okay, now by which least number we multiply this whole term? You multiply this whole term by 5 to make it a perfect square. So 900 is a perfect square. How we made it perfect? By multiplying 180 by 5. The next number given is 1008. Again, we'll follow the same steps. We'll start finding its prime factors. So let's start with 2. Now when you divide 1008 by 2, you get 504. Again, divide it by 2, you get 252. 252 is divisible by 2, you get 126. 126 on dividing by 2, you get 63. 63, if you divide by 3, you get 21. Now 21 is divisible by 3, you get 7. 7 on 7, you get 1 as the answer at the end. Now the next step is writing all these as the product of prime factors. 1008 can be written as product of all these prime factors. You start forming pairs. 2 and 2 forms a pair. Again 2 and 2 forms a pair. 3 and 3 forms a pair. If you see 7 doesn't have a pair. Now, if we want to convert this number into a perfect square, then all factors should have pairs. So if I multiply it by 7, 7 will also become a pair. So on the left hand side, divide 1088 by 7 and on the right hand side also. So by doing this, you will get a perfect square. Now 1008 multiplied by 7 gives you 7056 and on the right hand side, everything has a pair. 2 square multiplied by 2 square multiplied by 3 square multiplied by 7 square. Now find the square root of 7056. When you take square root, all these factors you take ones only. Those who are in pairs, you will take only ones. So the square root of 7056 is 84. Now by which least number I multiplied 1008? The least number by which I multiplied is 7 to make it a perfect square. The next number given is 2028. So again, we'll find the prime factors of this number. It is divisible by 2. Divide and you get 1014. Now divide it by 2. You get 507. 507 is divisible by 3. You get 169. See, 169 is only divisible by 13. Okay, so divide it by 13. You get 13. And on dividing 13 by 13, you get 1 as the answer. So 2028 can be written as product of all these prime factors. Okay, now the next step is formation of pairs. 2 and 2 has a pair, 13 and 13 forms a pair. Now if you see 3 is alone, now you want a perfect square. Perfect square means all factors should have pairs. So what you will do next multiply both sides by 3. Now, when you multiply 2028 by 3, you get 66084 as the answer. And on the right hand side, all factors have pairs now. It is 2 square multiplied by 13 square multiplied by 3 square. It means square root of 6084 is 2 multiply by 13 and then multiply by 3. So the square root of 6084 is nothing but 78. So the question was by which least number you multiplied to 2028 to make it a perfect square. So the least number is 3 to make it a perfect square and the square root is 78. So the next number is 1458. Now let's find its prime factors. Divide it by 2. We get 729. 729 on dividing by 3, you get 243. 243 on dividing by 3, you get 81. 81 you divide by 3, you get 27. 27 is divisible by 3, you get 9. 9 on dividing by 3, you get 3. And at the end, you will divide 3 by 3 and you get 1 as the answer. So it can be written as the product of all these prime factors. Now the next step is formation of pair. See 3 and 3 forms a pair. Again 3 and 3 has a pair and next 3 has a pair. But if you see 2 doesn't have a pair, it means if I multiply this whole term by 2, then 2 will also get in pair. So what we will do, we will multiply both sides by 2. So when you multiply 1458 by 2, you get 2916. And on the right hand side, 3 has a pair, again next 3 has a pair, 3 and 2 also has a pair now. So when you find square root of 2916, you get 3 multiplied by 3 multiplied by 3 multiplied by 2 and the answer is 54. Now the question was by which least whole number you multiply this term to get a perfect square. So that least number is 2 and the perfect square is 2916 and square root of that number is 54. The next number given is 768. Again, we'll find the prime factors of it. Divided by 2, we get 384. Again, it is divisible by 2. We get 192. 192 on dividing by 2, you get 96. 96 is divisible by 2, you get 48. 48 on dividing by 2, you get 24. 24 is divisible by 2, you get 12. 12 on dividing by 2, you get 6. Divide again it by 2, you get 3. And at the end, divide 3 by 3 to get 1. Now 768 can be written as product of all these prime factors. Now again start forming pairs. If you see everything has a pair other than 3, 3 is alone here. If I want to make this number a perfect square, it means I will multiply both sides by 3. So 768 multiplied by 3 on the left hand side, and on the right hand side 3 also have a pair now. So 768 times 3 will give you 2304, and on the right hand side all 2's have pair and 3 also has a pair. So the square root of 2304 is, you will take all these numbers only once. So you will multiply 2 multiply by 2, again by 2, and then 2, and at the end multiply it by 3. So the answer is 48. So by which least number we multiplied this 768 to make it a perfect square? So that is 3. And the square root of the final number which we received, 2304, is 48. Now let's start doing this question number 6. See, find the smallest whole number by which the following number should be divided to get a perfect square, and find the square root of the square number obtained. So this time, in the previous question, we were looking for the number which should be multiplied. In this question, you will find the number to be divided. So the steps will remain same. First of all, you will try to find the prime factors of the given number 252. And 252 we have covered earlier also. So if you find the prime factors of 252, what you will get? You can write it in this form. So 252 can be written as 2 times 2, then again multiplied by 3 times 7. So the next step is you will start forming pairs. Now if you see 2 and 2 forms a pair, 3 and 3 forms a pair, but 7 is alone here. Now what I do, if I divide this whole term by 7, then this and this will get cancelled, and then everything remaining will be in pair only. 2 and 2 and 3 and 3 are in pair. Then you will get a perfect square. So what you will do, the number which is alone here, which is 7, you will divide this whole number by 7. So on the left hand side, divide 252 by 7, and on the right hand side, when you divide this whole term by 7, the 7 will get eliminated, and you will be left with 2 square and 3 square. So when you divide 252 by 7, what we get? We get 36, and on the right hand side you get 2 square and 3 square. Now the new number formed is 36. Now find the square root of this number. When you find the square root of 36, you will get 6 as the answer. So the question was, by which number the following number should be divided to get a perfect square? So that least number is 7. After dividing by 7, the new number formed is 36, and the square root of 36 is 6. Come to the second question, 2925. See, all these sums are similar. You need to find only the prime factors of the given number, and the number which is not forming a pair. Divide this whole number by that number. Okay, now let's do this sum together. Now find the first square root of 2925. So we'll divide it directly by 5 because this number is ending with 5. It means it is divisible by 5. When you divide, you get 585. 585 is again divisible by 5. You get 117. 117 is divisible by 13. You get 9. When you know that 9 is divisible by 3, and again divide it by 3, and you get 1 as the answer at the end. Now you can write 2925 as the product of all these numbers. Now the next step is very crucial. You will form pairs. Now after forming pairs, if you observe that 13 is left alone, it doesn't have a pair. It means you will divide this whole number by 13 because you want to make a perfect square. So divide 2925 by 13, and on the right hand side, when you divide it by 13, 13 and 13 will get cancelled. So after division, what we get? You get 225, and on the right hand side, 5 and 5 can be written as 5 square, and 3 can be written as 3 square. Now our motive is to find the square root. So when you find the square root of 225, you will take only these pairs only once. So you will write it as 5 times 3. So the square root of 225 is 15. So by which least number we divided this whole term to get a perfect square? So that number is 13. And your square root of the new number formed is 15. See, maths is just like a puzzle. The more you practice, the easier the pieces fit together. Okay, now let's try the next sum. It is 396 given. Again, we'll follow the same steps. Find the prime factors, divide it by 2. You get 198. Again, divide by 2. You get 99. 99 is very easy to solve. It is again divisible by 11. You get 9. Divide again it by 3. You get 3 at the end. Now again divide it by 3 to get 1 at the end. So 396 can be written as product of all these numbers. Now again is form pairs now. 2 and 2 forms a pair, 3 and 3 forms a pair. Which number is alone here? Now you can easily see that 11 is alone here. It means if I divide this whole term by 11, I will get a perfect square because 11 will get eliminated and rest of the numbers are in pairs, right? So you will divide 396 by 11 and on the right hand side, 11 will get eliminated because you're dividing it by 11. So when you divide 396 by 11, you get 36. On the right hand side, 2 times 2 can be written as 2 square and 3 times 3 can be written as 3 square. Our motive is to find the square root. So square root is nothing but 2 times 3 and so the square root of 36 is 6. So in the question was by which least number you should divide this number. So the least number by which you should divide is 11 to make it a perfect square. And 36 is a perfect square and square root of 36 is 6. See, the next one is 2, 6, 4, 5. Now let's make its prime factors. So if you find the prime factors of 2, 6, 4, 5, you will get 23 times 23 times 5. So the next step is formation of pairs. Say 23 forms a pair, but 5 doesn't have a pair. That means you can simply divide this whole number by 5. So when you divide 2, 6, 4, 5 by 5, you will get 529 and on the right hand side 23 square. So when you find the square root of 529, you get 23 as the answer. So by which least number we multiplied this whole term to make it a perfect square. So that least number is 5. Now it's time for the word problem. See, all these word problems are very easy. Just read them very carefully. See, the students of class 8th of school donated rupees 2,401 in all for Prime Minister's Relief Fund. Each student donated as many rupees as the number of students in the class. Find the number of students in the class. See, we need to find how many students are there in the class. So just to understand it, let's assume that there are 9 students in the class. This I'm just assuming. Now, according to the question, each student contributed as much money as the number of students in the class. So if there are 9 students in the class, so each student will contribute how much rupee? See, there are total 9 students. So each student will contribute. So this student will pay rupees 9. This student will also pay rupees 9. So this will also 9. So all these students will pay rupees 9 only. Okay. So this is I'm doing just to make you understand. Right? It means how much money is collected. 9 times 9 which will give you 81 rupees. Okay, now in the current question, this was just for the example. In the current question, if you don't know how many students are there, so you will assume it. So instead of 9 and 9, you will assume any number. I am assuming n there. So you will write n times n. Then how much money is collected? 2401. It is given to you. And what is n here? N is number of students. And each student is giving how much money? N only. Right? So n into n will give you n square. So n square is 2401. So how you calculate n? N is square root of 2401. So now we'll see how to find the square root of 2401. Now let's find the square root of 2401. So this number is divisible by 7. So divide it by 7, you get to 343. 343 is divisible by 7, you get 49. 49 we all know that comes in 7 table. So 7 on dividing by 49 you get 7 and at the end divide 7 by 7 to get 1. So you can write 2401 as the product of these 7s, right? Now the next step is you will start forming pairs of similar factors. So 7 and 7 forms a pair and next 7 and 7 forms another pair. So it can be written as 7 square times 7 square. Now you are looking for square root. How you find square root? When you find square root, you will take these pair only once. So you will take one 7 and another next 7. So you can write square root of 2401 as 49. So what we assume initially, we assume n as number of students and each student will contribute as the number of students in the class. So this indicates that there were 49 students in class 8 and each student contributed rupees 49 for the Prime Minister's Relief Fund. Now, eighth question is also a word problem. See, 2025 plants are to be planted in a garden in such a way that each row contains as many plants as the number of rows. Find the number of rows and the number of plants in each row. See, just to make it understand, like what the question says. The question is that let's say there are three rows. See, there are three rows, one, two, and three. I'm just putting arrows for the rows. Then each row will have that many plants only. So if there are three rows, then there will be three plants. In each row, there will be three plants. So if you are making four rows, then each row will have four plants like this. Okay, so what these rows? These are rows and these are nothing but columns. So if there are three rows, there are three columns. If there are four rows, there are four columns. Right. Now we'll try to solve this problem again. So, so we don't know the number of rows and number of columns, but we know that there are equal rows and equal columns. Now we will find how many rows are there. Okay. Now, since we don't know the number of rows and number of columns, so we can assume it. So we are assuming that there are n rows and in each row there are n plants. So n plants means n columns. So in n rows and n columns, you will fit 2025 plants. So in another way, in mathematical term, how you will write it? You will write n times n is equal to 2025. N times n will give you n square, which is equal to 2025. Now you need to find n. So n is nothing but square root of 2025. Okay. Now let's find the square root of 2025. We already saw it how to what are the square roots of 2025 by prime factorization method. So you can write 2025 as the product of all these prime factors. Now the next step is formation of pairs. Form the pair and 2025 can be written as 5 square times 3 square times 3 square. Now you are looking for square root of 2025. So it is 5 times 3 times 3. So square root of 2025 is 45. So we assume n as 45. So it means 45 rows of plants are there and each row will have 45 plants. Okay. And how it will look when you will arrange 45 plants in each row, then it will look like this. It will be in the square shape form. Now we are at question 9. See, find the smallest square number that is divisible by each of the numbers 4, 9, and 10. See, the question says you need to find a number which is a square number, and when you divide that number by 4, you should get remainder as 0. And when you divide that number by 9, you should get remainder as 0. And when you divide that number by 10, you should get remainder as 0. Then how to find such sum? See, you will find LCM of 4, 9, and 10. So let's find the LCM of 4, 9, and 10. So put lines like this. 4 and 10, you know they both are divisible by 2. So when you divide it by 2, what you get? The 4 will become 2, 9 will remain as it is, and 10 will become 5 now. Now again, if you see 2 is there, it means again divide it by 2. Not in place of 2, you will get 1, and 9 will remain as it is, and 5 and 9 are not divisible by 2, so they will remain as it is. Now divide it again by 3. So 9 will become 3 and 5 will remain as it is. Again divide it by 3. So 3 ones are 3. So in place of 3 you will get 1. But 5 will remain as it is because 5 is not divisible by 3. Now at the end only 5 is left. So you divide 5 divide this whole term by 5 and you will get 1 at the end. Now since you got 1 at the end, so you can write the LCM of this number is nothing but write them in the product form. So it is 2 times 2 times 3 times 3 times 5. And when you multiply all these terms, you get 180. But do you think 180 is a square number? Can you tell me whether it's a square number or not? See, it is not a square number because if you see 2 and 2 forms a pair. It is in the pair form. 3 and 3 is also in the pair, but 5 is not in the pair form. It means 180 is not a square number. So what we will do, we will multiply. Now, if we multiply this whole term by 5, then the 5 will become 5 times 5. So it will also become a pair. So what we will do, we will multiply this whole term by 5 just to make it a perfect square. Right. So what we will do now, multiply it by 5 because 180 is not a square number. So multiply 180 by 5 to make a perfect square. When you multiply 180 by 5, you get 900. And if you see, 900 is that number which we were looking for, because it is divisible by 4 also, it is divisible by 9 also, and it is divisible by 10 also. Okay, so 900 is the smallest square number which is divisible by 4 and 9 and 10. Now look at question number 10. Find the smallest square number that is divisible by each of the numbers 8, 15 and 20. So it is just like question number 9. So the steps are same. We will find the LCM of 8, 15 and 20. How we find LCM? Write down these numbers. Now if you see 8 and 20, they both are divisible by 2. So let's divide them by 2. But you get 4. Now 15 is not divisible. So you will write 15 as it is and the 20 will become 10. Now 4 and 10, they are again divisible by 2. So again divide them by 2. 4 will become 2, 15 will remain as it is and 10 will become 5. Right? Now again 2 is there. So again divide it by 2. Now 2 will become 1. 15 and 5 will remain as it is. Now 15 and 5, they both are divisible by 5. So write 5 now. Divide both of them by 5. So 15 will become 3. 5 is divisible by 5, so it will become 1. Now in the final, you divide this by 3. Okay, now you can write this LCM in the product form. So LCM is 2 times 2 times 2 times 5 and then times 3. And when you do this multiplication, what you get 120 as the answer. Now can you think that 120 is a square number? See, 120 is not a square number because if you look at these factors, 2 and 2 is in pair. But this 2 is alone, this 5 is alone, and this 3 is also alone. But we are looking for a square number. Square numbers are those whose all factors are in pair. It means if I multiply it by 2, it will become a pair. If I multiply this 5 by 5, it will become a pair. And if I multiply 3 by 3, it will become a pair. It will become in a pair. So 5 twos are 10 and then 3. This means 30. So 30 is that number with which you need to multiply this whole term. So what we are going to do? We will multiply this whole term by 30. Why? Because 120 is not a perfect square. So when you multiply 120 by 30, what you get? 3600. And 3600 is that number by which all these three 3600 is divisible by all these three numbers. It is divisible by 8, it is divisible by 15, and it is divisible by 20 also. Right? So you can say 3600 is the smallest square number divisible by 8, 15, and 20. Okay, so this completes our exercise number 5.3. This was little lengthy exercise. So, okay, keep practicing more and more because maths is not about speed, it's about understanding, and you are learning beautifully. And if this video helped you, please do like and subscribe my channel. Thank you for watching.